Good morning, everyone. My name is Donna Chacon, and today I will be discussing the health of our oceans with regards to zooplankton communities, which leads me into my research question. To what extent have the marine species of zooplankton been affected by higher climate trends and forcing them to geographically shift from warmer waters towards the Atlantic Ocean? My argument is that warmer climate trends have increased water temperatures in the Atlantic Ocean because of the altered physical structure of the near-surface oceans, the integrity of zooplankton in Earth's climate, and recent hurricane patterns. So what are zooplankton? How does this geographic shift exactly happen, and what is the overall effect of it? So zooplankton are actually the smallest animals in our ocean. While some stay small microscopically, others grow into bigger species such as crabs and jellyfish. All of the animals in our oceans basically derive from zooplankton and owe their entire lives to them. But our oceans are changing as more of a quarter of carbon dioxide created by us humans ends up in the ocean, making the ocean more acidic and lower in oxygen as climate change creates these geographic shifts of zooplankton. The impact of this disruption not only affects the communities of zooplankton, but also affects all the other species in the food web. So as you can see here, we can see some effects of the geographic shift of zooplankton. Obviously, if you guys have taken any science class, you know that the red is warmer, blue is colder. So we can compare the warmer temperatures to the species that follow them. So we can see from 1958 to 1981 in comparison to 1982 to 1999, more recent data, that there are more warmer towards the left, which is closer to the Atlantic Ocean, which compared to here, which is just closer to the land, which affects the zooplankton communities and other species because it makes them shift geographically. Which leads me into my first point, that zooplankton diversity may be directly controlled by the physical structure of the near-surface ocean. In an article about environmental controls on the geographic distribution of zooplankton diversity, there's an explanation given that details the variation in physical and chemical properties that describe how findings indicate that the geographic distribution may be controlled by this factor. It states that temperatures of 50,000 and 150,000 are highly correlated to sea surface temperatures and explain the diversity patterns. Data collected from the same journal from heavily polluted waters in the North Canal River in China revealed that there was a leading factor to the change in the marine community, but they weren't really sure of what this factor was. So other scientists here in Florida actually observed the geographic shift of zooplankton after hurricanes, since we have hurricanes very frequently, and they saw that after Hurricane Irma and Harvey swept the Atlantic Ocean, they were followed by a vast undercurrent of zooplankton. So in a journal from Oxford Academic Files, the effect of hurricanes on the planktonic food web of a large subtropical lake in Florida showed that there was a higher biomass in composition where it was shown, which also showed the lower bacteria in zooplankton. So these scientists that observed these communities in Florida communicated with those in China and found that the biomass was the relation between the two. Which leads me to my third point, that zooplankton plays an integral role in the moderating of the Earth's climate because the geographic regions are defined in the study to provide an objective basis for investigation in the long-term dynamic, which basically, in other words, means that as the zooplankton community shifts, since every other animal derives from these animals, they're all affected by it, so the entire food web is completely destroyed. So many scientists and people just interested in this topic kind of get confused with this and don't really understand the full relationship between plankton biomass and the geographic shift. So I completed a couple of analytical data, kind of combining data from different sources, and made this chart, which basically shows the distribution of the plankton biomass throughout the years from 1960 to 2010, which shows that it's decreasing. So what I concluded, even though it's still under investigation, I believe that because of the plankton biomass decreasing, it is caused by the pH, ocean acidification, as the pH levels are lowering and causing more acidic waters, which is causing all the plankton to geographically shift. So the possible solution that I came up with was the regulation of improving the environment. So by creating like certain regulations that the government can make to create unity within the people to overall save marine life and ecosystems. But there's obviously limitations, such as differences between governments, where there's always going to be disputes between climate change, and just also that if climate change is unreversible, so damage done may not be able to be, we may not be able to fix it. Thank you.
All right, 2 questions I have for you. First up, how did your research question evolve as you moved through the process?
So my research question evolved because when I saw the topic, the health of overall oceans, I knew that I wanted to do something with marine life. But once I started investigating, I started collecting data from different sources in different parts of the world, from China to Florida, and started creating connections that made me create my own data as the chart that I made. So it made me really interested, and it made me kind of come up with these solutions and scientific ways to improve the geographic shift.
Okay, and if you had more time, what additional research would you have done?
I think I would have personally contacted through email other scientists that just focus on this with their entire lives on the plankton biomass, and just chemistry professors to really understand it and understand why they're moving and why the ocean acidification is increasing.
You're done.